Assalamu alaikum everyone. Today we'll be doing the second lecture of the topic probability generative function in further statistics of Cambridge further maths. In this topic we will be covering the probability generating function for the sum of random variables, which is a very important topic. Let us start with the formula for two independent random variables, probability generating function of the two independent variables together. That means the g of x plus y, this would be equal to the probability generating function of x into probability generating function of y. So, this is the formula by which we can solve the sums here. Now, let us start with this sum. A very simple sum, guys. If we understand the basic here, we will be able to do any difficult sum from the question paper. Now, it is given that the two discrete random variables x and y have probability generating functions g of x is this and g of y is this. Now, we have to find probability of x plus y less or equal to 3. Now, as you are asked to find the probability of this variable, so x plus y can be written as the z, the sum of two random variables. Now, we know the formula that this would be equal to g of x into g of y. Now, simply put the expressions of g of x here and g of y here and then multiply and expand it to get the expression for g of x plus y. So, we will be getting this one is the g of x as given in the question. Now, into this is the g of y as given in the question. So, this is the g of y. Now, if I multiply and expand this expression, I will get the probability generating function of x plus y. So, let us do that, guys. Now, here 1 by 4 and 1 by 3 is 1 by 12. Now, if I multiply this two, I will be getting t plus 2t cubed plus t to the power 5, and then with this I will be getting t squared, then 2t to the power 4, then t to the power 6. Now, from here if I multiply with this, I will be getting t cubed, I will be getting t cubed here, and then this one I will be getting 2t to the power 5 and then t to the power 7. Now, if I simplify this polynomial, I will be getting t plus t squared, then we have t cubed here and here, that gives 3t cubed, and then we have t to the power here only, so 2t to the power 4, and t to the power 5 is here and here, so it would be 3t to the power 5. Now, t to the power 6 is only 1, t to the power 7 is only 1. So, this is the expression for the probability generating function of x plus y. So, we will be getting, so this is the probability. Now, we are asked to find the probability of x plus y less or equal to 3. So, as you know that this is the probability of x plus y less or equal to 3. That means, here the power is 1, 2 and 3. So, I will take 1, 1 and 3, the first three expressions, the coefficients of these things. As you are asked to find probability of x plus y less or equal to 3, that means you should select the power 1, power 2 and power 3 and take the coefficients from there. That will give you the probability. So, to understand this topic, you must have covered the first lecture of probability generating function. Hope you have completed that and started watching the lecture number 2 of this topic. So, this is how we get the probability of x plus y less or equal to 3. So, this is our value 5 by 12. So, very simple sum to start with. Now, we can move to a sum directly from the question paper. You are prepared for that one. You will really enjoy how to proceed with these sums. So, let us start, guys. This is a sum that is taken from winter 2022 variant 4.1. Here the question is, Jason has 3 biased coins, not fair. For each coin the probability of obtaining a head is 2 by 3. So, obtaining a tail would be 1 by 3. Jason throws all 3 coins. The number of heads obtained is denoted by x. So here the random variable x indicates the number of heads. Find the probability generating function of gx. So to do this part of the sum, you need the concept of lecture 1. So first of all, I need to find the probabilities of each and every value of the random variable. So if we think that how many heads can we get? We can get 0 head from here, from the 3 tosses. We can get 3 heads, 3 tails, that means no head, 0 head. We can get 1 head, HTT. We can get 2 heads, that is HHT. We can get 3 heads. So these are the possible outcomes that can that we can have. That means we can have x, the value of x0, the value of x1, the value of x2 and the value of x3. Now we need to find the probability of this thing, and to find this we don't need to we don't need the concept of further statistics. This is a very simple concept of S1. Now here we can get 1 by 3 to the 1 by 3, 1 by 3, each trial should be multiplied, that gives you 1 by 27. Now here head is 2 by 3 and then 1 by 3 whole squared, or 1 by 3 times 1 by 3, and you can have 3 possible combinations from here. So that will give you 2 by 9. Now you are getting 2 by 3 whole squared into 1 by 3 into, you can have 3 possible combinations from here. So that gives 4 by 9. Now from here you can get 2 by 3 whole cube, that gives 8 by 27. So these are the probabilities of the values of x 0, 1, 2 and 3. Now how to form the probability generating function? Very simple guys. Take the coefficient here and t to the power the value of the random variable. So it would be 1 by 27 plus 2 by 9 into t to the power. T will take the power of what? T will take the power of the possible value of the random variable, and the coefficient of coefficient of t would be the probability. So here the probability is 2 by 9, the value of x is 1, so it would be t to the power 1. And the next one, probability is 4 by 9, value of x is 2, so it would be 4 by 9 t to the power 2. So 4 by 9 t to the power 2. Now probability is 8 by 27, value of x is 3, so it would be 8 by 27 to the power 3, t to the power 3. So this is the probability generating function for x, for Jason. So this is the first part of the sum. Now let us move to the second part of the sum. Jason also has 2 biased coins. He throws all 5 coins. The number of heads obtained from the 2 unbiased coins, the rest 2 is unbiased. That means probability of head is half, probability of tail is also half. So the probability generating function for the next 2 coins are given. Now the random variable z is the total number of heads obtained when Jason throws all 5 coins together. Now we have to combine. We have to take one random variable x, we have to take one random variable y, and then we have to generate the probability generating function of z, and here z is x plus y. So here comes the contribution of this lecture here. So today's lecture we are covering the sum of 2 independent random variables. So here we have to follow that one. So we know that g of x plus y is equal to g of x into g of y. So simply do that. Here z is equal to x plus y. So g of x into g of y. Now put the expression g of x from here. We will be getting this one into the probability generating function of y. So put the value here guys. Now we have to expand it simply and we get the expression in polynomials. So 1 by 27 I am multiplying, first of all I am taking common from here so that it gets simplified. 1 by 27 I am getting this into, from here if I take 1 by 4 as common, it would be a very simplified version. Now if I multiply this two, it would be 1 by 108, and then simply multiply all of this. So 1 plus 2t plus t squared, and then we have to multiply the rest of the part. So if you do the expansion here, very simple task guys. So do the expansion and you can check your answers with mine. This is the final answer you have. So this is the probability generating function for for z, where z is equal to x plus y. We are combining, we are summing up the two independent random variables. Now, we have to write down by expanding the brackets. Actually, you can keep your answer in this form as well, but I would suggest don't take any risk, express as polynomials, simple polynomials without any factors. So, this would be the expression for the probability generating function for z, x plus y. Now, you are asked to find Ez, and from the previous lecture, lecture number 1 on this topic, we know that Ez is equal to first derivative of the generating function, and the value of t would be 1. So, if I take the probability generating function here, how to get the first derivative? Just differentiating it just once. So, 1 by 20, 1 by 108, if I differentiate 1, it would be 0, 8t, 8, 50t, then this one differentiation 114t squared. Now, differentiating this one 112t cubed, and this one differentiation 40t to the power 4. Now, I have to find first derivative, the value of the first derivative at t is equal to 1. So, get the value of the first derivative at t is equal to 1, put 1 in place of t's. So, it would be 8 plus 50 plus 114 plus 112 plus 40. So, I am getting 3. So, that means E of z is equal to first derivative and put t is equal to 1. So, you will get the Ez. So, that is all about this sum. You can see that the sum of this sum contains total 3, 3, 6 and 2, 8 marks. So, very important one. Huh? Now, let us move with the next sum. It is taken from winter 2022 and the variant 42. A 6-sided dice A with faces number 1, 2, 3, 4, 5, 6 is biased, so that the probability of throwing a 6 is 1 by 4. Throwing 6 is 1 by 4. So, not 6 should be 3 by 4. The random variable x is the number of 6s obtained when dice A is thrown thrice. So, if dice A is thrown thrice and I am concerned about getting 6s, so what can be the outcomes? I can have 0 6, I can have 1 6, I can have 2 6s, and I can have at best 3 6s. Sorry, it was thrown twice, sorry, at best 2 6s. It was thrown twice, not thrice. So, 0 6, 1 6 and 2 6. So, if I get 0 6, that means no 6, no 6, no 6. That means 3 by 4, 3 by 4. It was thrown twice. So, 3 by 4 into 3 by 4, it would be 3 by 4 squared. It was thrown twice. Now, it is 9 by 16, 1 6, that means 1 6 and 1 6 prime, 1 by 4 into 3 by 4 into 2. There can be 2 possible combinations here. Now, 2 6s, that means 1 by 4 into 1 by 4. So, 1 by 16. So, these are the probabilities and these are the values of the random variable. So, probability generating function would be 9 by 16, 6 by 16 t to the power 1, then 1 by 16 t to the power 2. So, that is all. This is the probability generating function of x. Now, let us move to the second part of the sum. A second die B with faces 1, 2, 3, 4, 5, 6 is unbiased. That means the probability of getting 6 must be 1 by 6. Y is the number of 6s obtained when the dice is thrown twice. Z is the total number of 6s obtained when both dice are thrown twice. So, you are asked to find the probability generating function of z. The first of all, you need to find the probability generating function for y. So, if I get if I throw this dice, 2 die unbiased, that means fair. So, I can have 0 6, I can have 1 6, I can have 2 6s. So, if I have 0 6, that means 5 by 6 whole square. If I get 1 6, that means 1 by 6 times 5 by 6 into 2. There can be 2 possible combinations, and 2 6s, that means 1 by 6 whole square or 1 by 6 times 1 by 6, that gives me 1 by 36. So what would be the probability generating function? 25 by 36 t to the power 0, 10 by 36 t to the power 1 and 1 by 36 t to the power 2. So this is all about the probability generating function of y. Now we need to get the probability generating function of z. That means we have to apply the formula. What is the formula, guys? Generating function of x and generating function of y. We have to find the product of those two. Now put the expression here. This is the gx from the first part of the sum and then the gy from the next part of the sum, part b, this one. Now I have to simply expand it to get the probability generating function. So do the expansion, guys, and you can check your answers with mine. And don't keep anything in factor form. Huh? So I will always suggest to not to take any risk. Don't keep the constant as a factor. Expand it. So be in safer side. So this is the probability generating function of the z. Okay, now let us move to var z. What is the formula of var z? You can learn it from the first lecture of this topic. Second derivative of the generating function and put value 1. First derivative 1, first derivative 1 whole squared. So now for z, I need to find the first derivative and second derivative. That is my first start. So let us start with the probability generating function of the z. Now if I differentiate once, I will get the first derivative. So differentiating these expressions are very easy, the concept of P1. So n x to the power n minus 1, this is the only formula that you require here. Second derivative, what to do? We have to differentiate the first derivative here. Now let us do that, guys. It would be 0, 188 and then 96t and then 12t squared. So I have got the values. Now I can get second derivative's value at t is equal to 1 and first derivative's value at t is equal to 1. So if you put the value here, you can use your calculator to get the value. It will come 5 by 6. And now if you put the value of t1 here, you will get the second derivative's value at t is equal to 1. Now I know these values, just simply apply this formula to get the values of var z. So var z is equal to 37 by 72, then first derivative's value 5 by 16, then minus 5 by 16 whole squared. Now you can use your calculator to get the final answer and it would be 47 by 72. So this is the var z. Now the last part of the sum is a very interesting part. Use the probability generating function of z to find the most probable value of z. Most probable value of z, that means the value of z that has the highest probability. So if I observe the probability generating function here, I should pick up the highest coefficient, and if I look at the highest coefficient, the largest coefficient here, it is 240 probability generating function of z, that means it is 240 by 576t, or we can say 5 by 12t. So it is 240 by 576t. And if I take this term, I do understand probability here is this, and the power of t will give me the value of z. That means z is equal to 1. So as the power of t is 1, that means the most probable value of z is 1. The concept is very simple. Look at the probability generating function. Take the largest coefficient, take the term with largest coefficient. This one is the largest coefficient, that means this one has the highest probability here. And now we all know that the power of t indicates the value of z. So here the value of z is 1. That means, as mentioned in the question, what is the most probable value of z? That means I need to find the value of z which has the highest probability. So the value of z should be 1. So that's all about this sum, guys, and that's all about the lecture as well. Thank you very much, guys. Take care. Assalamu alaikum.